Hello and welcome to this v0.3 version 0.3 video tutorial, and in this video tutorial I'm going to quickly cover how to do a shadow study analysis with the v0.3. The shadow study analysis, although it's a contextual analysis which tells us for defined points within our scene how often a point will receive shine or will be in shadow, assuming perfectly clear skies all the time. It's got some of the characteristics of some of the more complicated or involved analyses that we can do, which I'll cover in subsequent videos. So the basics of a shadow study analysis is firstly to have some geometry, which will either be shadowed or will cause shadows, and to define within the scene where we're going to calculate or define the location of the points for which we're going to calculate how often they're in the sunshine and how often they're in shadow. So what we do for the shadow study analysis is we can create specifically some geometry. So I'm going to get rid of this circular ground plane, and instead I'm just going to, let me just move this plane to the ground and scale it up by, that'll do. Actually, I might do it a little bit less than that just to keep things quick for the purposes of this video. So I have here now a ground plane, square ground plane, and this plane is going to act to determine the sensor points for the shadow study analysis. So in Blender I can shift to edit mode, and we can see that when we first create a plane it only has one face and 4 vertices. So if we chose faces as the way to determine the location of our sensor points, we would only have one sensor point here in the middle, and if we chose vertices we'd only have 4 at the 4 corners of the face. But we want to show or analyze which points are in shade and which points are in the sunshine with a little bit more resolution than that. So once I'm in edit mode for this plane, I can press W and subdivide, and I can increase the number of cuts with this operator panel here. This panel often appears when we do in Blender what's called an operation. So if we extrude, or if we create an array, or in this case if we subdivide a mesh, we get usually some options appear in a window on the bottom left here, and it's the number of cuts I want to change. So I'm going to change it to 29. So we now have 30 faces by 30 faces on this sensor plane. So now we'll be calculating shadow and sunshine for each of these either faces or vertices. So we've set up the sensing geometry. We do now, however, need to tell the v0.3 that it's this geometry which is going to be the shadow sensor and not the geometry associated with our buildings, for example. So with this plane selected, I go to my Blender Material tab, and I can add a new material to that object, and I can call that ShadSense. At the bottom of the material panel, we have a v0.3 Material tab, and instead of Material Type Geometry, we want Material Type Shadow Sensor. Once that's been done, the v0.3 now knows that all geometry with the ShadSense material applied to it is a shadow sensing geometry. And as this material has been applied to this face is now designated within the v0.3 as a set of positions of shadow sensors. So now I can simply add an analysis node. I can add a v0.3 shadow study node, and I've just got to connect the location out socket from the VI location node to the location in socket of the shadow study node. Once that connection has been correctly made, we've got some options in here about what period of the year we're actually going to do the shadow study for, whether we're going to have an animated scene or a static scene. These animations are set up within Blender. And I won't cover the process of creating animations in Blender here. There are lots of resources on the web that will help you discover that. So I'm just going to stick with a static analysis here, but I can control the start month and the end month. So if I only want to look at the patternation of shadows and lighting for the first 3 months of the year, I can just put March, month 3, as the end month. I can also select what period of each day within that monthly range I'm interested in. So if I'm only interested in how these sensor points are lit or shadowed in the morning, I can, for example, put start hour 9, end hour 12, which is also midday. I can then specify the interval at which I do calculations, or which the V-Suite does calculations. And if I set it to 1, then we'll do 1 calculation per hour within this valid hour range and within this valid month range. But I could set it to 0.5, for example, and then we'll do a calculation every 30 minutes. This menu option here defines whether it's the center of the faces of our sensing geometry or the vertices of our sensing geometry, where we're actually going to do the calculation as to whether that point is in the shade or in the sunshine. And if we're using complex geometry for the sensing geometry, sometimes we need to increase this offset value a little bit. But in general, you can leave that as it is. So now if I press calculate, then the V-Suite will, for each point on this sensing plane, and for each hour and for each month that we've selected, it'll work out if that point is in the sun or if it's being shadowed by another object within the scene. Once that calculation button has been pressed and the calculation has completed, then we have, again down here in our V-Suite display tab, some options for shadow study display. The first toggle is to define whether we want to be able to do a 3-dimensional projection of our results plane. So I'll turn that on. And then the only other option is to actually now display the results. So if I press shadow display, we can see now the patternation on our sensing plane of where these points will be in sun, or how often these points will be in sun, and how often they will be in the shade. So if I just get rid of this sun for a moment, and there's a little bit of overlap between the results plane and the original plane. When we press shadow display, we create a totally new plane which contains all the colorations of the results. So we can then, once we've pressed shadow display, see some other options made available. We can choose to turn on the legend, and if we turn on the legend, that relates the coloration of the plane to the percentage of time that that position is in the sunshine. So we can see, for example, that to the south of our buildings, and remember that positive Y within the V-Suite is always north, to the south of our buildings, the ground for this period is always in the sunshine. There's no shading geometry to create any shadows here. But on the north side of our buildings, we can see that obviously this building is causing some shadows on the ground, and this building is also causing some shadows on the ground. And because we chose to look at the morning when the sun is predominantly over here, you can see how two sides of that shadowing are slightly different. We can change the scale of our legend here if we wish. We can change the legend scale, but that's more important for lighting analyses, which I'll cover in a future video tutorial. This simply turns on and off the wireframe for our results plane. Because we had 3D display turned on up here, when we press shadow display, we can change the 3D projection of our results plane, higher results leading to higher projection. So it's just a way to three-dimensionalize our results a little bit. We can also set transparency of the results plane if we wish to see some geometry behind it. And this section here controls whether we visualize a numerical value for each point on our sensing geometry. So because I had vertices selected here, we can see that we have a numerical value associated with each vertex. So, for example, this point in space, this point on our ground, within the period we specified here, was actually in sunshine for 41% of the time. But if we go to some of these points directly to the north of the building, I maybe change the font color, we can see that some of these points were in sunshine for 0% of the time. They were completely in shadow for all of this period. Within this point visualization dialog, we can turn on whether we only visualize the numbers for the points that are visible within the scene. It's not perfect, there's a bit of overlap, but it can clean up the display of results a little bit. And we can change whether it's only the currently selected object that we visualize points for. So as this building is now selected, and I've chosen selected only, but it has no numerical results associated with it, we don't see any numerical results. But if I select the results plane, we suddenly again see those numerical results. And if some numbers don't appear, then again, increasing this position offset number can help with that. And finally, we have this display active option, which should be turned off when we finish displaying our shadow study results. So that's how it works if we create sort of bespoke geometry for to act as sensing points for the shadow study. But we can also, I'll just turn off display for the moment, we can also have our actual building geometry specified as sensing geometry. And all we have to do in that case is to say, for a particular geometry, I've got two types of material associated with this geometry. I've got the walls material, which is associated to most of the building, but I also have this glass material, which I have associated with each pane of glass within the building. And if I specify that this glass material, instead of being geometric, is a shadow sensor, and I do my calculation again, and it might take a little bit longer this time as I have subdivided each of these window panes into a number of panes. So there's actually quite a few calculation points for the shadow study to go over. Once the calculation is finished, I can press shadow display, and we can see that if I turn off point visualization, we can see now that we have that coloration, that darkness and lightness, showing whether a surface, whether a point, what proportion it's been illuminated by the sun and not for our simulation period appears on our windows. So we can, per normal, bring up a numerical display of what's going on for each point in those windows. And again, because we did vertices, these numbers appear at each vertex of the plane. And that can be done for really any geometry within the scene that we wish. So it can be very handy to see, for example, the effect of changing the height of this building, say, on the shading of this building. Oh yeah, I also had the glass material of this building set up as a shadow study surface, and because all these windows are on the north face of this building, none of them get any sunshine, direct sunshine, any of the time, so the results are 0. So it's quite a handy tool for working out how much shadowing is going to be imposed on windows around the building that you can adjust or you're designing, etc. So I think that's about everything. I think the 3D visualization of results tool can also apply to those window objects. And if we had selected faces here, I might just do that calculation quickly with the faces. And once that's done, if I now display that and change my 3D view, what I might do actually is the ground plane, I might turn off that ground plane's shadow study ability, shadow sensor ability. So just change that back to geometry. You calculate again. That still thinks it's, it is a wrong plane, sorry. Shadow study to geometry. That's the glass material that is a shadow sensor on the building. Calculate again. And once that's completed, do shadow study analysis. And for example, now when we visualize 3-dimensionality, you see we get these kind of extrusions of the particular faces. So we can see quite clearly there, our upper windows are getting the most sunshine, and it's our windows here in this lower left-hand corner from the perspective that I'm looking at it that receives the lowest direct sunshine based on this period that we chose to simulate. Okay, and I think that's everything you need to know for shadow study analysis. Okay, thank you. Thanks for watching.